Okay, so let's see how we can look at the characteristics of the charging process and define a certain kind of quantity of time that will tell us how fast this capacitor charges. And it will be a way to compare different capacitor RC circuits and see how fast they charge. So let's look at the charge as a function of time. This is the plot. Asymptotically, it goes to infinity to this value, E times C. And then let's define a certain time called tau, and we define that time to be R times C. Now you can say, now why is R times C, why does this have units of time? We'll show this in a while, why when you multiply resistance times capacitance, it gives you something that has units of time, but we'll do that a bit later. But for now, if you put time equal to R times C, then you get here, instead of the t, you put R times C, you have R times C over R times C, you get just 1 minus 1 here. And what is 1 minus e to the minus 1? This is just a number. If you calculate this number, what would you get? You'll get the number 0.632. That means when you put the time equal to tau, that tau that we defined, which is R times C, the value of the charge is what? It's 0.632 of the maximum value it'll ever get. So that's basically what the definition of the time constant is. That's how you could define what tau means. Tau is just the amount of time it takes for the charge on the capacitor to reach 0.632 of its maximum value. And this is useful for what? Because if you take an RC circuit and someone tells you the tau for this circuit is 1 hour, then what can you conclude from that? You can conclude that it's going to take 1 hour for the charge to reach 0.632 of its maximum value. If someone else gives you a circuit of tau 1 millisecond, then you can see that one of the circuits is going to charge much faster than the other. So this is a way to characterize the charging process and see how fast it goes. You can also define tau for the current. So when the current decreases with time, we can also do the same thing. So let's put equal to tau equal to R times C and see what the current becomes at time tau equal to R times C. When you put time equal to R times C, you get e to the minus 1. E to the minus 1, when you calculate the value of it, turns out to be 0.368. That means that the current, when you put time equal to tau, the current becomes 0.368 of the maximum value it had. So this is basically how you would define tau if you want to define it in terms of the current. You would define tau as the time that it takes for the current to decrease to 0.368 of its maximum value. And this again gives you an indication of how fast the current is decreasing in the circuit. So this is another way to characterize the charging process of the capacitor. Now, to get back to the issue of why the units of time constant are R times C has units of seconds, well, resistance is volt over potential over current, and capacitance C is equal to Q over V. The V's will cancel. You get something that has units of charge divided by units of current. Now, charge is in coulombs and current is coulombs per second. So you can see that the coulombs will cancel, and 1 over second give you units of seconds. So R times C has units of seconds.